What's up, Fire Dogs? Have you joined our Facebook mentorship group yet? The group is called Fire Dog Mentorship, and it offers members the opportunity to become mentors or to seek mentorship from a collection of Fire Dog leaders. I can tell you that I've connected with two great leaders, and they give me a lot of valuable advice on what my next career move should be. And although the conversations continue, they've given me a lot to think about. It's great to hear their different perspectives. The group also has learning units, which essentially is a repository of documents, videos, and websites for firefighter learning and development. There's material for firefighters, officers, senior officers, and much more. To join the group, go to facebook.com/groups/Fire Dog Mentorship and click join to be a part of the experience.
This is the Fire Dog Podcast.
The views and opinions presented on today's episode are those of the speaker and do not necessarily represent the views of the Department of Defense or the United States Air Force.
Welcome, my name is Matt Wilson, here with 𝗵𝗵𝗃, and thank you for joining us for episode 18 of the Fire Dog Podcast. Our guest today is a lieutenant assigned to Shaw Air Force Base Fire Department in South Carolina. He led an effort in his department to transform nozzles and attack fire hose used on their fire engines. The attack package, as it's known, is intended to increase firefighting effectiveness by increasing water flow, decreasing nozzle reaction, and encouraging better hose handling tactics. Here with us to share the details of the effort is Lieutenant Whit Dodson. Welcome, Whit. It's great to have you on.
Thank you. Thank you very much. It's an honor to speak with you guys today.
We're excited to hear about the hose and nozzle project that you and your team completed there at Shaw. Before we get into the details of that, I'd like to see if you could tell us a little bit about yourself. How long you been in? Do you have a military background or anything? And how long you served?
Yes, sir. I've got a short military background. I'd like to preface everything we say today with that I'm not an authority on engine work by any means. It's an honor to speak with you guys and try to help get the message out for the Air Force. And I'll do my best to refer to those who influenced me and tell you how we did it. As far as my history, I was a little bit of a knucklehead growing up. I didn't have much direction and always worked hard, didn't try to hurt anybody, but at the same time, I didn't want anybody to tell me what to do. And then I met my now wife. And since then, I was age 19 when I met her. Life has improved dramatically. And if not for her, I don't know where I'd be, honestly. I had kind of an unorthodox childhood. My grandmother moved in with us with Parkinson's disease when I was 14 years old until I was 21. And some of the sacrifices, my wife made no bones about that, saw me, grow through that. And she would get off third shift work in a telephone operator job and come and help me with my college studies and little things like that. Everything that I did, I was a youth baseball coach. She'd come to games and things like that. Always put family first. And we don't see things through the same lens. So that, helps me pretty greatly. Oddly enough, she thinks she's the lucky one, but it's actually the opposite. And she's been a great influence and teammate in my life. As far as my Air Force journey, I was taking an EMT class and there was a flight medic there. And I was interested at the same time. I learned about Air Force pararescue and he said, well, Whit, there's two types of people. There's people who go for it and those who don't. And that changed my outlook on my path because I was slated to do EMT school and then go through fire school. I was interested in becoming an Orlando firefighter. That's where I'm from originally. And that changed everything for me. I dropped fire school. I completed EMT, but I thought with pararescue, I wouldn't need EMT necessarily because I was going to be a paramedic through that program. So I was excited to get started. I talked with a recruiter, talked with the special operations liaison down at Patrick Air Force Base, witnessed a pass test, and I was like, I'm hooked. I went to the YMCA, trained for that 5-6 days a week, 6 hours a day, really worked hard, cut my work schedule down because I was in a hotel. I was in a hotel manager's position. And then I cut my work schedule down to accommodate for training. And I went for it. And unfortunately, here was a 3-day period where I took my pass test on a Monday. That's required for pre-entry to special operations. And then my mom was diagnosed with Alzheimer's dementia on a Tuesday. And then the third day, I went to MEPS to swear in. And when the recruiter or when the MEPS liaison officer asked me, do you still want to join? Because I was H2 hearing, I have asymmetrical hearing loss in my right ear. And he said, do you still want to join? And I was like, yes, I do. But shaking my head, no. I didn't know what to do. I didn't have a plan B at that time. And fortunately for me, I was selected for fire protection. That same recruiter who had helped me overcome a lot physically said, you got fire protection. I can honestly say that I've hit a home run. I've hit the jackpot getting fire protection. I've worked for and with a lot of great people and still do today. A lot of mentors on the military side, a lot of mentors on the fire side. I'm lucky to be at Shaw, where we run, we have a strong mutual aid agreement with Sumter County, EMS, fire, great mentors there in the city also. All those calls that we've run here, and I ended up being a Sumter volunteer on the EMS side and the fire side. But all those calls I've run, they're all reps, they're all practice. Nobody wants anybody's stuff to burn up or anybody to get hurt, but those are opportunities for us to do our job and solve problems, which is what we do.
How long have you been in Air Force Fire Service? What year did you join up?
2011, November. So this is it'll be my eighth full year in the fire department for the Air Force. So I did. When I got here at Shaw after tech school and basic, I got here in 2012, June, and I was here until October of 2015 when I got out. And I volunteered the latter part of my Air Force active duty career here. I volunteered with Sumter County Fire and then came back as a civilian. I am blessed to come back as a civilian in this department, same place, so didn't have to learn any too many roads and things like that. Some of those, buildings I'm familiar with some of the people and some of the tactics. And so got the job in 2016 after a short stint at Avon Park, Florida. The transition, I'm not going to lie, the transition was really hard to get out of the military. And as I said, I didn't get in to get out. It's just my mom's health was not good. And my son was going to be born in 2015. And my wife's perspective changed. It became a lot more family centric, whereas I think I was thinking of it in terms of, well, it's a good thing, and I already miss half of everybody's time. But I think it changed for the better for us. But I will say that I have a great deal of respect for the dual hatter military fire service professional, and I appreciate it. Everything that the military folks do for us.
Well, we respect your decision to get out, certainly with your family situation. And it sounds like there's a lot of background.
Sure.
You're working as a volunteer, and then you're spending a lot of time on Shaw and in that department. And you led an effort there at Shaw to study and to change out hose and nozzles. And you shared some material with us, a PowerPoint in a news article, which we'll mention later. It looks like a great thing, and we're really curious to know more, and that's why we brought you on. So what initiated that effort to change nozzles and hose?
Initially, I'll go back to my early days as an airman and a firefighter. I'm not even good at math. So when the hydraulics section of pumper came up, I just beat it into my brain that I need to understand this to be successful. I started going over condensed Q, and I'll have an example of that here in a little bit. But I knew the hand method very well. I knew these ways of doing business, and I love the way there's a fire officer named Matt Hinkle. He's actually now a PhD, but he taught it on YouTube, and the concepts matched our CDC. So I'd sit with airmen who were in pumper as the years went on, work the problems with them. I've done that a lot. So if we work back a little bit from that, if you think about it, NFPA 1710 requires career departments to flow 300 gallons a minute. They call it maybe 300 gallons on the ground at a residential structure fire with one line minimum of 100 gallons a minute. All right. So nationally, it's accepted practice for, I guess, the ease of the pump operator and effectiveness of gallons per minute to BTUs on the fire ground, that the lines are flowing 150 gallons a minute each to get that, to meet that requirement. So if we did the condensed Q for the flow of 150 gallons a minute, and it's really hard to say this without demonstrating, but if you think of the coefficient, because it all kind of starts here, and then we'll get into the why, why we changed it and what changed my opinion. But the condensed Q for C is 15.5. So that coefficient for inch and 3/4 line is 15.5. The Q for flow, let's go with 150 for gallons a minute, because we're using the same diameter and the same length line. So 150 over 100 is 1.5, and all of that gets squared, and we'll do that in a second. So then you get your length, and our pre-connects are 200 feet. So we divide that by 100. So now you've got a formula or an equation, technically, of that friction loss that's going to be created in the hose is 15.5 times 1.5 squared, which is actually 2.25, times 2, because we have the 200 over 100. So if you do all that math, right? So 15.5 times 2.25 times 2, you get 69, and I think it's 0.75. It's either 2.5 or 7.5, but I think it's 2.5. Anyway, roughly 69 PSI friction loss in the hose. So that's the way I taught, and that's the way I knew. And then I was an attendee at FDIC Fire Department Instructors Conference 2018, and I took a course called Real World Hydraulics with a man named Kirk Allen. And he asked how we knew, he asked the forum how we knew what we were flowing out of the line. And I raised my hand. There was people like Dennis Laguerre and a lot of fire service professionals in there. And I replied theoretically, because mathematically, that's how I knew. I knew what that coefficient was for a given flow at a certain length. And then I knew what I was going to be, I thought I knew what I was going to be flowing. And to that, he answered, yeah, but how do you know? How do you know what you're flowing? And I mean, the crickets were surrounding me, and I just didn't know what to say. And we'll get into knowing the flow and how we accomplish that now a little bit later. But I also took Battalion Chief Kurt Isaacson's gallons per second class, very powerful class. And there I began learning about how Pensacola and Escambia County went about their nozzle study. And he also brought up the U.S. FEMA email notification of civilian fire fatalities in the United States and firefighter fatalities. And that kind of brought me to my why. Why learn about any changes? He brings up a good point. He says, it doesn't matter. Nothing matters except what you do with your crew while you're on shift. I think that's a great quote on mindset. And I've been able to reach out to Chief Isaacson and some of these folks I'll mention in a minute for resources. I still know and teach condensed Q and the hand method. Brian Brush, to me, says it best when he reached out. He told me this on one of the new Elkhart Brass Tacks live series that they're putting on. Don't confuse certification with education. And it's great to have firefighters know theoretically, those numbers can and they do change when you're working on the line, but they still have to become certified in the pumper CDC. There are still requirements. And until that changes, they need to know those numbers. But when they get on the line, and especially when they're an actual pump operator and using our equipment, they need to know the difference between certification and education.
So back to the question, is that the basis for why you change out the hose and nozzles? Because you get more of an accurate flow, or you have to rely less on hydraulics, or?
Great question. Yes, I might not have even answered that. Our main purpose was reducing nozzle reaction while increasing flow for firefighters on the scene. We started making changes because as you dive into the subject, you end up learning so much. There's so much more involved than just the equipment that we have that's sort of given to us. So yeah, there's a big thing, and I've got some specific stuff to talk about regarding nozzles and then hoses and then flow meter, but yeah, there's a lot to it.
Well, let's start with the nozzles. So here in the Air Force, we usually see a pretty standard collection of 100 PSI automatic nozzles. Can you explain to us the different type of nozzles that your department moved to?
We moved from 100 PSI variable gallons per minute nozzles to constant fixed gallons per minute nozzles. And the two that we chose are a 7/8 inch smooth bore nozzle and a 160 gallons per minute at 50 nozzle pressure. And we did that because the hydraulics match. So whether you're flowing a 200-foot line at 7/8 inch smooth bore, you're getting 160 to 161 gallons per minute. Or if you're flowing the 160 at 50 combination, both of them are low pressure, high flow, again, to reduce exertion on the firefighter, which allows them, to move, actually water map and do some of the things you need to do with an open nozzle, not have to shut it down as often. So we get 50 PSI at the tip for our attack lines, on our 1 3/4 lines, on all pumpers, our ladder, or our aerial or stick, and our tanker. That allows for less nozzle reaction for the nozzle firefighter, down from 77 pounds force, which is how that's measured. It's measured in pounds force. So 77 with the 100 PSI automatic nozzle to 57 or 54 pounds force, depending on the nozzle reaction for 7/8 or 160 at 50. We've got a lower pump discharge pressure and discharge pressures for a pump operator. If you think about the condensed Q, if you're adding that 69 and 70 PSI, or you're using the hand method of 72, what you're having to pump at or get that pump discharge pressure to is roughly 170 PSI. So that delivers 77 pounds force of nozzle reaction into that nozzle firefighter or nozzle team. And really what Paul Grimwood of the London Fire Brigade published a long time ago was that 60 pounds force was the maximum that one firefighter is going to be able to handle effectively, especially to keep the nozzle open. But anyway, now we're at the 86 PSI at the discharge gauge. And that gives us, again, that 54 to roughly almost 60 nozzle reaction for the nozzle firefighter. So we remove pistol grips from our nozzles. So that's a training issue, just as chasing kinks is a training issue. If you think about it, there's an orifice, the internal diameter of a hose. If it goes from large to small, if there's any bending of that at low pressure, it would be more susceptible to kinking, which is going to make the firefighter more susceptible to a reduction in flow. So chasing kinks is a normal fireground operation. I'm not saying there's, 1,000 kinks in a line, but that's a normal fireground operation that makes us do some work on the scene.
So these aren't necessarily any kind of new technology or special. These are just carefully chosen in order to meet the goals of, kind of reducing firefighter strain and flowing GPM easier, if I'm hearing you right.
Yes, absolutely. Nothing new here. And from manufacturer to manufacturer, you can take, whether it's hose or nozzle, and you can spec those out yourself. Your department can. You can create a nozzle committee, but this is nothing new. It's been going on in the American Fire Service for 20 years. So a lot of the work we've done is piggybacking off of the folks in the American Fire Service who have been studying this very closely for 20 years now.
And to put it in layman's terms for firefighters like me out there that may not be picking up on all the details. So you get less pump discharge pressure. You get the 300 gallons at the door with 2 lines. There's less nozzle reaction, about 57 to 60 pounds force. And so you're getting the same amount of water with less nozzle reaction. And that's the reason that you guys steered in this direction?
Yes, definitely. 300 gallons a minute, we're getting 320. So we're exceeding NFPA 1710. We're exceeding the National Fire Flow Formula by National Fire Academy with less wear and tear on pumps and less exertion from nozzle firefighters. And if you think about backing this up scientifically, it is more effective since smoke is just as deadly as fire, whether it's orange or black with high velocity. And that's backed up by Charlotte Fire Department's Andrew Starnes, who has a gamut of studies on thermal imaging and thermography, showing that heat, the rebound effect of shutting a nozzle down. So it's more likely that a nozzle firefighter is going to shut that nozzle down if, one, they can't see what's above them, and two, if it's too hard to handle. Those are two major pieces there. And then just doing the work, it all comes down to training. Try to gator arm a pistol grip like I did when I was a young firefighter. I was fighting a defensive 2-story structure fire, a house fire, and I was lobbing water up into trying to bank it off what was left of the ceiling and roof members. But I was cooked after a very short period of time. So a lot has to go to hose management and hose handling and not gassing ourselves too early. But some of it comes to having the right equipment.
And I talked a little bit with you about this previously. So I mentioned Aaron Fields to you, and you told me that you're familiar with him. He leads the Nozzle Forward, or he created Nozzle Forward, which is a program on hose management technique. You bring up great points on people shutting off the bail or alligator arm, pistol grip into the armpit. I can't tell you how many times I've seen that personally or done it myself. And what ends up happening is we close the bail just enough so that we can handle it. So we end up with less gallons per minute, which the whole intent of those automatic nozzles was to reduce the pressure, which what we end up doing is we're forcing our firefighters to close the bail a little bit more so that they can handle it, right? And then you have alligator arms, so you don't have effectiveness of your stream. And so we're not meeting the intent of the NFPA. We're not doing the best job that we could do. So if I'm understanding what you're saying.
Yeah, 100%. 100%.
The different nozzles are going to help us meet our intent of 300 gallons at the door, a more ready firefighter, a more ready fire department.
High flow, low pressure. Absolutely.
And I've actually went through Aaron Fields' Nozzle Forward. It was a 2-day seminar, and it probably had the biggest impact on me as a firefighter more than any other seminar or class that I've taken personally. It's really eye-opening what he shows you, and the techniques that he shows you never force you to close the bail. You always have an open bail. You always have that 7/8 inch tip. Well, not always, but there's solid bore. There's no pistol grip, and you can keep the bail open. You can do it with 2.5 inch line too.
Absolutely. I wish I could have taken Fields' class at FDIC, but I haven't. I've listened to the lecture. Unbelievable. That guy is so succinct in being able to communicate how to learn, not just, and how big of a responsibility it is for him and me by proxy, or me by adopting his mentality of it's our responsibility to teach people how to work, is the quote he uses. And we have so many young airmen, young firefighters who are impressionable. And if we show them early that this stuff matters, then again, just by adopting the passion that we have, it's going to translate and move the ball, move the chains, move the ball forward.
I took his class in probably 2015 or 16. He's an inspirational guy.
Truly. I love the guy.
So let's move on and talk about hose. So we talked a lot about the nozzles, and we read through your article that was published in the FES newsletter. It's the most recent one, the first quarter newsletter, I believe. You mentioned in the article that you use combat ready hose, or that you transition to a combat ready hose. What's the difference between that hose and the hose that we typically use or we typically see?
Well, kind of as we talked about, from manufacturer to manufacturer, or even within the same manufacturer, there are big differences in hose construction. Combat Ready is a design by 𝗘𝗽𝗃, and that's one of the manufacturers. And if you're thinking about fire hose, you're thinking about a lot of different things, but with a low pressure, high flow system, you want to get as close to an internal diameter, the hose's internal diameter of 1.75 inches. And Dennis Laguerre is a huge inspiration on hydraulics and water supply. He's a retired firefighter captain from Oakland. And he, if I could refer anybody to any data, it would be his study on, it's an article called Nozzle Dreams and then Hose Dreams. He goes way down the rabbit hole. But seeing as that, I just assumed that hose was hose, when I thought, well, this is fire hose. When we first got a flow meter, I realized how big of a difference it was. We talked about pumping and pump discharge pressure before. Even with a low pressure nozzle, I was having to pump part of our hose at 160 PSI, whereas the Combat Ready, in this case, 𝗘𝗽𝗃, was only pumped at 86 PSI to 90. It's hard to read that discharge gauge sometimes, but that's a big difference. And that the discrepancy led me to Laguerre and Brian Brush and others who have studied this, the Freeman ratio, which is how you can spec out nozzles based on the Freeman ratio or Freeman standard, which is the nozzle or the orifice opening, in our case, a 7/8 inch tip. That 7/8 inch is 1/2 the internal diameter of the hose that we're using. And if you want to get really specific, the 7/8 America's tip is designed for their line of true ID, which means true internal diameter, 1.75 inches internal diameter, or 1 3/4 inch is 1/2, 7/8 inch. 7/8 is 1/2 of 1 3/4. So that internal diameter is really important there for hose. We matched it as closely as possible, and Combat Ready hose is doing well for us too at the 160 at 50.
So the hose that we traditionally see is a little bit smaller of a diameter, internal diameter, and the Combat Ready is bigger. Is that what I'm understanding?
Typically, actually, a lot of the hose produced, and there wasn't a whole lot of oversight. Laguerre talks about it in some of his lectures, that there wasn't there's a tolerance that the hose industry is held to, and just because a hose manufacturer says it's an 1 3/4 line, it can be almost 2 inches. So it's important to try and match the nozzle with what hose line you're using. Now, 1.88 inch, as that internal diameter gets larger, and say you have a large tip, like a 15/16 tip, and honestly, 1/16 of an inch of orifice is such a huge difference, but that creates more kinking because I can't put this to an analogy, but it creates nozzle whip and poor hose management when the tip is not small enough and it's not kind of spec to that ratio. There are specific notes on it, but really, if you think about the main point, as fire departments over the years have become all hazard or all risk, as we're called, departments, the knowledge of our own equipment and knowledge overall has decreased. So I think there's a really big importance of getting vetted processes by field practitioners, people like Laguerre, either bringing them in to teach and develop SMEs in a department, train members who are currently there, attending local conferences, as you know, Matt, that it's just a huge value to us, getting that outside information. Not that what we're getting is bad, it's just we're now able to synergistically share, even through, this platform, through podcasts, and it kind of closes the gap of education. Powerful stuff. Yeah.
With the advent of technology, you move further and further away from technical competence. I think you lean on some of those technologies to solve the problem for you, but you make a great point with that. Back to the hose and nozzle. What's the ideal combination of hose diameter, internal diameter, and nozzle orifice size? Because you mentioned that they have to be in sync with each other for it to make sense. And that was the whole idea behind combat ready hose, from my understanding.
Yes. And even more specifically, ideal would be if you look up the old plumbing and then eventually fire hose of Freeman, he talks about that ratio was named after him. It's one, that orifice size has to be ideally 1/2 of the hose's internal diameter. So if you do the math on it, 7/8 inch is 1/2 of an 1 3/4 true, and that's called true ID hose.
You mentioned in the article that it took about 2 years to complete all of the testing and training that you guys did. Can you walk us through the testing process? What exactly did all of that entail?
Sure. So when I went to FDIC, I was writing notes as frantically as I could. I started reaching out to some instructors. I mean, if you think about it, time takes time. Everything takes time. When you come back from a conference or something like that, you're not and I'm still not the authority on really anything, but it's taking what people who have done it time and time again and trying to apply it to your life. But I started reaching out to some of those instructors. I researched more. I trained on our past practice. I tried to make that better, learning more about air and fields. But we ended up inviting a vendor out, and he helped us with our nozzle study. He showed us, and he gave us a printout of what we were flowing before, with and without kinks. And we attempted to manage hose and do some different techniques in and out of a building. And then he gave us, with the low pressure system, he gave us some other options and showed it, the printout side by side. And right there, it becomes pretty easy to see. And he had a flow meter with him. He had an external calibrated digital flow meter that connected to our truck and to our hose and to that nozzle. If you think of it as a whole, as an attack package, he brought all of this equipment, and we were able to test it out and play with it. And after all of that, I went to a class called Engine Operations out at Fort Jackson. And they started talking about target flow, reaching target flow and understanding same situation that I started learning about before. But combination of those things led us to have a successful nozzle study and start the process of, so it begins in education. It then kind of goes to training, and then it goes to equipment purchases, because we had none of that. So
the training process, was there a drastic difference in kind of the common hydraulic theories that needed to be retaught, or is it all stuff that we've known all along that maybe we're highlighting different portions of?
Okay, well, that's really two questions. It didn't change the way we advance hose. We're following Fields' clamp slide, hip grip, crooked lean, and 𝗍𝗃𝗻𝗄's lock off, knee walk, single firefighter advance, go into the left, go into the right. The Brass Tacks series puts on a lot of good stuff by Brian Brush, Jeff Shoup, Ray McCormick on hose management, water mapping, and how, Fields again talks about the inverted U, wall ceiling, wall floor technique of training. So that didn't really change from high pressure to low pressure. It just brought it to the forefront. It brought engine operations to the forefront, at least in my eyes. And I started learning things like making loops and managing kinks, making loops to advance line more quickly, attack oversupply, and just managing hose in hallways, in a straightaway, different. Another thing I learned at that class was how to make a Minuteman. So it kind of goes back to different ways to fold hose. Triple layer can be limited for a lot of departments, especially if there's it's great if there's no set, a long setback. And there's a couple ways to manipulate the triple layer. But if you use a Minuteman or a flat load, even flipped upside down, you can put 100 feet of hose in about a 15-foot space. that with a AAA or with any kind of obstacles, you're just not going to be able to do. We're lucky because we've got short setbacks at Shaw, so we can do what's called an alley pull and pull all of it out. One side is the nozzle, the other side is that first loop that we're so used to seeing. And then we take that and the first coupling, we take the nozzle and the first coupling up to the door for a single story residence. So you have that first 50 feet at the door.
Did you put all of this in writing? Is it in a PowerPoint presentation? How are you teaching new firefighters that show up at the department all of this?
On the job.
So they're looking at the automatic nozzle in tech school or a certain way of doing business in tech school. They show up to Shaw. Did you guys formalize the process? How do they learn about everything you've talked about so far?
Great question. The rookie book comes into play there. I love that. It's not just that 803, after entry anymore. It's these airmen, and we have 2 of them. Our brand newest airmen are walking around with that rookie book. And I have a lot to add institutionally, just because I've been here for a long time. But I think there's a lot of value for young firefighters because they're going to see, and if they remember it or not, I can still show them, a brass tacks series on the automatic nozzle. And it shows that, spring that's compressing when the nozzle's when the bail is open to allow water to flow through versus what we have. It's the ability to add to our way of doing business that's improved so much because of this study. And we've got airmen who are a lot newer than me bringing some great ideas to the table. And it's just having the guts or having the open mind to try them out. Like, that's the way I see it. When someone brings up an idea, I don't like to say, well, this person says this and this person says this. I like to say, well, let's go try it. We've got the equipment. Let's go try it. Let's see.
Have you experienced any kind of pushback or, resistance to these kind of non-Air Force standard nozzles and maybe some more advanced techniques? Or do you get those maybe airmen that come in that are a little more, I don't want to say apathetic, but just kind of caught in the routine of the Air Force system? If they've been at 2 or 3 other bases that didn't do it like that, they walk in and you're doing it different. Maybe they don't like that so much. Have you experienced that?
Actually, no. And I have to say that it comes down to the airmen that we get and the leadership. So whether they're at a brand new tech schooler who comes to Shaw, if we start them out right, they're going to, that's our responsibility, especially me as a civilian. I don't have a lot of the duties of an NCO that has, you've got troops. And so that's that first line supervisor. I've got some of those same experiences, but I don't have to have that relationship with the airmen. So I think everybody wants to learn. I really do. I think that the youngest person to the senior airmen and staff, young staffs that we get to techs, they want to understand, from their level. And they do. If they can see it, it's going to be a lot more effective. And I'm out there doing it with them. It's not just that, hey, go do this. That's not how we're going to do it. But, without that, it's once again, I bring up synergy. It's really empowering to have a discussion with an airman where the light bulb turns on. And I think that comes from the support from our leadership here and across the Air Force. You guys, putting this information out for people. Anybody can do this. They just have to do it. I want to bring up a story real quick. If you don't mind, I wrote this down. It really meant a lot to me. I had an airman, I guess I don't have to read the writing exactly, but I had an airman. We practice a lot of different stuff here. I'll bring back 𝗘𝗽𝗃𝗀𝗀 again. He says, how good is your department at doing the things that you can control? Control what you can control every day, which is how good are you at masking up, stretching lines, forcing doors, throwing ladders, making a stretch, flowing water, searching, victim removal, those types of things. How good are you at the things that we can actually control? I think that's so powerful. So we do a lot of mask up stuff at Shaw, trying to get faster, a lot of resources on that. But I had an airman come up to me. They had a house fire. I was not on shift that day. We had been working real hard on masking up. And he called me the next day again, I wasn't on shift. He called me and said, "Hey, we had this fire, this and this happened." But he said, "I was ready for that fire. I was ready." And because of the mask up stuff we've been doing, he wasn't slow on the uptick. And that meant that meant so much to me. And I've gotten texts from guys who say, "Hey, thank you for, whether it's be hard on me or thank you for caring about it." And it means a lot to me. I didn't think it would, but that was one of the most impactful things I've heard.
In your article in the newsletter, you said something that stood out to me. You said the transition stimulated conversations and shifted the culture. And that sounds like a good example of that culture shift there with that story with that airman. Throughout the whole transition from start to, I don't know if you're finished or if there's still more work to be done, but from when you started to now, at least, how was it received by the department at large? Was there kind of an unfreezing period where people might have been resistant but grew to love it over time, or was it an immediate, hey, let's do this?
I think once we brought in the vendor and everybody got to see what, the differences in what we were flowing, and then the hose management piece, I think they were really, we've got great chiefs here. We had 3 that day in attendance who were watching what was going on. And it wasn't just me, it was them. I was involved, a little bit, but I brought the guy here, and he did he showed everybody what I was already learning, and they got to learn it for themselves. So no pushback, none of that. It was just, it was well received. And then I'm kind of a nut in that I'll send little links to things that I get that I think will make sense, and from people who speak about it more appropriately than I could. And I send them to those people because I think they need to hear it or see it.
So far, we've talked pretty extensively on engine work and the attack package on an engine, the nozzles, the hose. Have you integrated this any into the aircraft firefighting stuff? Have we put it on the crash trucks?
Not yet. Good question, Matt. And I'm looking to do that in a lot of our high-rise packs this year, and try to understand, the Air Force as a whole, as an enterprise, seems to be moving toward ultra-high pressure and kind of a European model, if you will. And I am very interested, just as I was when I started learning about foam and compressed air foam as an agent or effective agent, maybe even more so than water, hazards notwithstanding. But I'm definitely interested in looking at the crash side of the house for this too. Agent is agent, but from a fuel perspective, when we're fighting fuel fires, especially large ones, I would like to see more data on this, and then move toward either going big water or true ultra high pressure, which is defined as over 2,000 PSI, not the 1450 that we're flowing out of the RIV. I think there's some work to be done there for sure.
I'm sure there was an initial investment, getting started with this, changing nozzles and hose. I'm curious, as a kind of mid-level leader in your department, how did you sell that to the department? I mean, I know you mentioned bringing in the contractor to kind of demonstrate, but was there a financial portion to it where you kind of had to justify, okay, hey, we're going to spend this many thousands of dollars. What's the benefit to do this kind of technically? Are we saving money elsewhere in engine repairs or nozzle maintenance, anything like that?
I'm not able to quantify that specifically, but those two things, it makes sense to me that if something's not working as hard, either the people who are doing the job in exertion and maybe strains and sprains, et cetera, and then down the line, injury claims and things like that, to pump wear and tear. I think there's definitely some savings to be had if the pump's not running as hard. In our case, it's not anymore. But if other fire departments are interested in looking into this, there's some no cost or very low cost options for people. I'd like to explain that because, the education piece is important here and the training piece, but with the education, two areas or ways come to mind. And the first one is what they call a time to tank test. So if you're holding any nozzle with any hose and you've got water in your tank, as long as you start a timer, just a regular stopwatch timer, once your line is fully impregnated or filled with water, and then open the nozzle, you can work backwards and work mathematically to find how much water you're flowing and how long it takes to basically cache your tank. So that's one way of doing it. That's a no cost way. It also helps pump operators key into their tank lights or sensors and work on communicating with command when they're talking about water levels on a scene. But the second way that's no cost is inviting the vendors to the department who have flow meters, gauges, different nozzles where they can test your current equipment against the stuff that they have. And I think both of those options are good and important. The education piece, though, being vital, knowing the work that has already been done at conferences like Water on the Fire, 𝗱𝗄𝗄𝗃 Beach, Exponential Engine by Brian Brush, All Things Engine at Charlotte Fire Department, Jonah Smith, all of these people, Dennis Laguerre at Laguerre Engineering out of California, all of these folks have been doing this work, and they can show specific savings. I can't at this time because it's only sort of new for us, but another great point is the nozzle maintenance, automatic nozzles with springs, et cetera, as per manufacturer, have a good bit of maintenance that's supposed to be done. And if you think about, I'm not trying to plug smoothbore. I don't want to go into the debate on smoothbore versus fog. I have my personal preference, but if you think about it, Laguerre talks about it as a binary operation. The bail is either open or closed. And one of the things we did here at Shaw is remove the split ball. If you take off the cap of a nozzle, and we used to have a split ball, which was advertised as opening the bail more smoothly, open and close it more smoothly. Well, again, that comes down to training. We now have a full ball, full waterway cut through. It creates less turbulence. With the split ball, there's two openings and there's bevels that cause turbulence. And that's going to lead to stream degradation. And that's something we don't want. We want the big three to be accomplished, which is, good reach of the stream, good gallons per minute flow, and then good combat mobility. That's Isaacson's plug on the big three. And at the end of the day, we're talking about putting water on the fire. We're talking about application of the water and getting it on the fire, not the duration that we're flowing. If you think about this, before we started doing this, a lot of pump operators were setting a preset at 125 PSI with our 100 PSI nozzles. And if you do the math, that only equates to 95 gallons a minute flowing. So it's less than the minimum NFPA 1710 requirement. So what we're looking to do is simplify the process. And something that flow meters do for us is we truly know our flow so that at 2:00 in the morning, a pump operator doesn't have to start doing the hand method or hope they don't try condensed Q pumping a fire. But all these formulas are not going through their heads. It's simplicity. Like Brian Brush talks about, a room or rooms on fire is 1 3/4 line. A residential floor on fire is a 2.5-inch line, and a fully involved structure fire is a deck gun operation. And it goes from 300 to 500 or 600 to 1,000 gallons a minute, respectively. But he also says we are drowning in information and starving for wisdom. I can relate 100% because I can dilute even my own message, and I'm sure I have today.
How do you integrate this into the heavy mutual aid abilities that you guys have? I know you interact a lot with mutual aid partners there. How are they taking it, or do they understand what's going on, or are they already doing it?
Great question. A lot of the mutual aid partners we have are running 1,000-gallon engines, and we at Shaw have a 500-gallon engine. It's a tank capacity. So it's a rural area, not heavily hydranted for sure. So we have to train together and develop tactics that are going to work with us. I mean, if you think about it, the first two engines, it will have 1,500 gallons of water, but we might be on scene for several minutes and we've only got a 500-gallon tank. So they've taken it great. I mean, they've got people come into the same classes, attending those same classes. So a lot of that information is we kind of go back and forth. They've got a lot of real world experience from a rural fire department perspective that at an intermediately spaced hydranted first due that we have at Shaw, that's a lot of it. And that's a different story. But we're lucky because we've got people who have been in the fire service for a while and they understand rural operations and drop tank and drafting from a lake and things like that. I mean, we've got a captain on our shift who really leads the charge in training and lives in a rural area and has been around the fire service for a long time. So still passionate about the job. And that's another huge motivator, is just having people who are wanting to push.
Well, Whit, you just mentioned, you stole my word that I was going to give you, and that's passionate. If there's anything that we can say about you in this whole episode and time recording so far, it's that it's clear that you're passionate about this. And I'm glad because, people have different passions in life, and we need someone who's passionate behind the pump panel.
Thank you. That's my job. That's my job as an engineer. I take it as an honor to understand this stuff and be good for the unprotected lungs and skin of civilians we've sworn to protect. It takes 3 minutes and 47 seconds for a room to flash now. We're not talking about legacy construction and legacy furniture. We've got poly, ISO, cyanurate, built furniture. Everybody's got it in their homes. The heat release rate is much faster. So we really have to focus on what we can control. And that is, like we talked about, the masking up and these things, it's just so important, that is so important. Maybe this conversation will add to some folks' passion. We have to remember that, like Babe Ruth said, yesterday's home runs don't win today's games. The people who need us to help them out don't care. They don't, as somebody else said, they're not looking for a fraternity. They're looking for professional firefighters. And since our time is so compressed now, we have to be really good at those operations that no one else is coming to. Nobody else is coming to a fire except the fire department. We've got medic backup for EMS, all kinds of different people who are coming to help us. We've got a hydrogen leak on the flight line. We've got HRT coming. But in a structure fire, whether people are involved or property's involved or both, that's why we have to be at our best. That's the main why.
We've talked about a lot today. You've covered a whole lot of information. If an Air Force Fire Department wants to institute a change like this in their department, where should they start first?
Good question. Either start here, or I would suggest that they look at Dennis Laguerre's work again, Paul Grimwood's work, Brian Brush's work.
What about Whit Dodson's work? Where can we find that?
Well, I wrote a PowerPoint on what we did here at Shaw, and it goes through what nozzles that we have here now and what we used to have. It shows what hose and the discrepancy we mentioned earlier about one type of hose requiring a much higher pump discharge pressure. And then it shows our testing equipment, which includes now, if you end up purchasing any of the equipment, I guess the first place I would start is, other than getting a vendor in, which is free, they have external digital flow meters and inline gauges that we have here. We've got, and the setup goes like this. Since water is not compressible, we have a 2.5-inch pipe with a little paddle wheel that plugs into the digital flow meter. So much easier to show this than say it. But that shows us in gallons per minute what's flowing through that pipe, whether it's, water in is water out. So whether it's on the hydrant side or the hose side, you have to put some adapters if you're flowing 1 3/4. But that's why it's great to flow off of a hydrant, because if you've got a 3-inch line with 2.5-inch couplings, you've got your intake on the engine and the 3.5 or 3-inch line going into the pipe. You've got your digital side set up there. And then what you can do is there are inline gauges. You've got a less rugged, it's a traditional inline gauge that can be 2.5-inch coupling or 1.5 inch. We've got them both. And then we've also got the 1.5 and 2.5 varieties of a rugged, which is a better application for right near the nozzle, because if that moves around or gets banged around, it's a more rugged build. And all manufacturers have those, and that gives you pounds per square inch. So if you have it right near the pump, whether your truck is calibrated properly, you've got a calibrated external PSI gauge right after the pump. You've got it right in front of the nozzle. And if you want to get really specific, you can get an external pitot tube that'll go, measurements are different for smooth bore and fog, but they're attainable. So that's after the nozzle. And if you want to get super deep into it, you can even purchase a fish scale to try and measure nozzle reaction. And it's measuring it in the pounds force converted. So that's what we did. And, I created a PowerPoint and a attack package innovation project, and come on down. Come on down to Shaw and flow some water.
Well, if you can give that to us, we'll put it up on the podcast side as a minimum.
And on the Fire Dog mentorship page, of course.
Absolutely.
Okay, great.
Hey, is there anything else you'd like to share with the listeners before we wrap up here?
Again, I really respect the dual hatter, which is the military and firefighter. I understand from experience what it's like to go through that at the lowest level on both sides of the military and civilian. It's an honor to work in the fire department. And if I can offer one thing, it would be if you can develop a plan while you're on shift of spending 3 hours per shift, one on education, one on training, and one on physical fitness. I think in 20 years, we'll be talking to those people about how far they've come. But if they can develop that way and maintain that discipline, I think that our fire service and our public is going to be better because of it.
Great way to end it, Whit. Thank you so much for joining us. Thank you for sharing everything you've done. Again, we really appreciate your passion, and I look forward to sharing all of this material with our listeners. Thanks for joining.
Thank you.
Thank you for listening to this episode of the Fire Dog Podcast. You can find more content just like this regularly posted on our Facebook page at facebook.com/the Fire Dog Podcast. That's facebook.com/the Fire 𝗷𝗶𝗰𝗍 Podcast. Please don't forget to subscribe, rate, review, and share this podcast with your friends and coworkers. This is host Matt Wilson with co-host Ben Perry and guest Whitney Dodson. Until next time, stay safe.